We are past the era of the flying camera. Today, heavy-duty drones are living inside weatherproof enclosures on industrial sites, opening their doors and launching themselves into high winds without a human in sight. For years, commercial drone operations were anchored to the ground. Even as these machines evolved from consumer toys into professional tools, they still required a pilot standing in a field, physically holding a controller and watching the battery drain. Now, systems known as drone-in-a-box handle the entire flight cycle. A localized base station acts as a permanent shelter, autonomously managing takeoff, precision landing, and rapid charging. By removing the requirement for a human operator, the aircraft stops being a temporary tool you pull out of a truck. It becomes permanent, 24/7 data-gathering infrastructure. You can see the immediate financial impact of this constant aerial surveillance in heavy civil construction. This is Pix4D Mapper Pro. It uses millions of automated drone data points to create precise 3D models of excavation sites. By comparing exact cut and fill volumes, contractors have indisputable records of completed work, routinely saving tens of thousands of dollars in settlement disputes. The speed of these automated platforms is also saving lives. Under the Drone as First Responder program, police departments in cities like Chula Vista, California, are automatically dispatching docked drones to 911 calls, arriving on scene in an average of under 94 seconds. Getting a live aerial feed to dispatchers in a minute and a half allows units to identify active hazards, allocate the right medical resources, and de-escalate volatile situations long before an officer's boots ever hit the ground. If autonomous aerial systems can instantly map quarries and intercept emergencies, it raises an obvious question. Why aren't they stationed on every city block and industrial site already? The hardware is ready, but it hits a hard regulatory wall known as visual line of sight. Under standard rules, a pilot is legally required to keep the aircraft visible to their naked eye at all times. Flying beyond visual line of sight, or BVLOS, requires proving to agencies like the Federal Aviation Administration that a remote machine won't crash into a news helicopter or a passenger jet. To get permission today, companies have to deploy expensive stopgaps. They mount heavy detect and avoid radar systems on the drone, or they station a daisy chain of human visual observers across miles of terrain just to watch the sky while the drone flies. Because operators have to petition for special case-by-case waivers for every new mission profile, the approval process can drag on for up to 2 years, severely restricting large-scale commercial rollouts. To fix this, regulators are drafting performance-based frameworks, like the proposed Part 108 rule in the US, which will standardize the requirements for autonomous flights, making them routine operations rather than special exceptions. This legislation relies heavily on unmanned traffic management, or UTM. This is a digital infrastructure layer that acts as an automated air traffic control for low altitudes, automatically coordinating flight paths and deconflicting traffic on the fly. Establishing these standardized rules and traffic networks is the absolute prerequisite for scaling commercial operations. Without them, the multi-billion-dollar autonomous economy stays permanently grounded. But a fully automated, connected sky introduces a massive security liability. When a drone is wired directly into a corporate cloud, it becomes a flying network endpoint. One of the most common attacks is GPS spoofing. If a drone relies on satellite navigation to guide its autonomous mission, that signal can be hijacked and replaced with false coordinates, pulling the aircraft miles off its intended path. Hackers can also target the information the drone gathers. By feeding manipulated inputs into the system, they can corrupt the data packets training the drone's artificial intelligence. The machine then learns to ignore serious security breaches or overlook critical sculptural defects during inspections. If the command and control links lack proper encryption, bad actors can quietly intercept the live telemetry and video feeds, gaining a real-time aerial view of proprietary manufacturing facilities or secure government compounds. Because a compromised drone can physically hover inside a restricted perimeter and bridge an air-gapped network for above, a traditional ground-based firewall is no longer enough to protect enterprise data. That same three-dimensional access applies to the physical world, and criminals are already deploying their own off-the-shelf drones for malicious purposes. Law enforcement agencies are facing entirely new threat profiles for large-scale events. For international sporting events drawing dense crowds, like those at MetLife Stadium, an unauthorized drone represents a risk that standard ground security simply cannot intercept. Because they easily fly right over barbed wire and checkpoints, organized crime groups frequently use them to smuggle illegal drugs and weapons directly into prison courtyards. Stopping these intrusions requires specialized counter-UAS technologies. Facilities are now installing networks of radio frequency scanners and dedicated radar systems to track low-altitude airspace, detect unauthorized controllers, disable rogue aircraft, and stop the approach. Securing this new frontier means adopting a physical and digital zero-trust architecture. As the technology matures, the ultimate test for the aviation industry won't be about who is holding the controller, but how we maintain safety and security when absolutely no one is.